Okay, so for types of stationary points, as I said earlier, you just need to prepare the gradient table. I think we'll just get started with question 2 straight away, and I'll see what question you guys will have as I go through these questions here. All right, Charlie, what are the steps to do these questions?
Derive.
Very good, derive, and then?
Make y, make the derivative equal 0.
Yep, and then?
Find x.
Yep, and then?
And find the y coordinate.
No, you don't need to. Not for this one. They only ask you for x coordinates.
Oh, okay. Well, then just what the nature is.
Yep, and then find the nature using the... Yep, it's called the... What's the name of it? What kind of table is it? Sarah, do you remember the name of the table? What's the meaning behind the derivative? It gives you the equation for the... Yes, so the table is called the gradient table. Yeah, so the word gradient is actually used quite a lot in unit 3. Okay, so the gradient table. So yeah, that's it. Go. Just start from let me specify which question. So you start from question A and then C and E, A, C, E. Just these 3.
When you use y though, when x equals 0, the gradients.
It'll be negative.
Actually, don't worry, I'm being stupid.
Make sure you make the final statement, yeah, on like the what type it is at each of the x coordinate. What question are you on, Sarah?
C.
C? Okay. Right, that's the answer for C. Okay. Okay, I think I'll do you guys a favor and not ask you guys to do question E. After 2C, move on to question 3A. So note 3A is about you have to sketch the graph by finding the axis-intercept as well as the actual coordinates of the stationary points. So question 3 is a little bit longer than question 2. You just do everything from question 2, but also find out the intercept and the y coordinates of the stationary point for question 3. Okay, so we'll just do 2A and C and then we'll move on to question 3. Just do the one question 3A. Right, if you can get 3A correct, I think I'll let you guys go for question 3. Oh, Charlie, just 3A.
But how am I supposed to? Do I have to use 1/2?
For, yes.
Use 1/2.
But yes, you have to use 1/2. That's why just one question from question 3, okay? Just 3A, and then we'll move on. Getting close, Charlie, to the end of this. To the end of all these derivatives. And we'll move on to antiderivative next week. We'll move back there next week. Got that, Charlie? Oh, very good. Just be very careful with your stationary point inflection. The gradient should be like about horizontal around there. Because the bottom, I can criticize that the bottom section there is too sharp. The gradient there is not zero. It has to be like horizontal. Right? If I were to criticize that shape there. All done? Tara?
I got confused with the table.
What about the table?
Okay.
Which part of the table?
I don't know what 1/2 squared is.
It's 1/4. 1/2 squared is 1/2 times 1/2, and you times it across. This is 1/4. I think the most of the other part of this chapter is about the same. This question 3 is like the one that covers the majority. Oh, wait. Okay. Next question is 13. Question 13 is the same idea as question 3. So you gotta find stationary points, x and y intercepts, and sketch it. Question 13 is the next one. Alright, Tara, any question for me? Any question, Charlie?
No.
Make sense? Okay, try.
Yeah, but you've already done it, so it's just like cheating.
No, it's not cheating.
It's cheating.
Remember the example I gave you like ages ago? I asked you to read, like, do you recognize the McDonald's sign? Yes. Can you draw it? Not really. It's the same thing here. I think the answer is one thing, but you know.
I can draw the McDonald's sign.
Try.
Done.
That's what most people would draw, but you know the actual McDonald's logo is a bit different. It's not just a simple
I
M.
don't have a yellow pen.
You don't need a yellow pen. You can just draw the shape of it, but the shape is also different.
Beautiful. And here's the people on top.
Look, if you really want me to show that, here. So if I want to analyze this, right, it has some thickness. You see, it's not just the single line. It has some thickness, right? And look, if we were to analyze it, see that thickness there. The bottom has a thickness, and then the line it slims down a little bit towards the top before it expands again. And the thickness of the top, it ends here. That's a sharp point, but the bottom is it's like a base. You know, from a logo design point of view, it's done this way so that it looks like the foundation is strong. You see, like the foundation of the M is strong. It's not just a simple M like that. Right, the foundation is strong, and then this one actually it will end up top here, right, and then the bottom here also has and it has a curve up. So this is not exactly the same, but it's still a slightly closer, like a cousin of the actual McDonald's logo. So that's what I'm saying. Like you may see it, and you're like, oh yeah, I can do this, but not really. You have to actually try to do it again by yourself. It's the same with math. When you see my answer, is only, and that's not the full answer. I haven't even sketched it yet. So if you can see, understand up to this point, you can just, oh yeah, I get it, and then just do it, and then you can continue. Right? So it's not cheating. I don't consider that cheating. I consider that as getting assisted. It's just an assisted like homework, like question, problem solving. That's okay. Slowly you get to the point where you can do something like this question here all by yourself, and that's question 14. If you can do question 13 with my help, try question 14 without my help and see if you can work it out. It's like almost the same thing. Sketch a graph of something. Well, actually, no, 14 is a bit different. This chapter, the questions are all different. So yeah. Any question for my explanation of my working there so far? No? Sarah?
When you find that x's intercept, you just substitute it into the original.
Yeah, x intercept is just sub x equals to 0, find the y-intercept, and sub y equals to 0, find the x-intercept. Alright, and then you sketch it. Go. Try the question. Get started on it. Finish it.
It's a bad question.
This is the question that uses the new concept that. Let me see if I can find a cosine. Oh yeah, I see it. But it's a complex familiar one. And then after this, we'll do question 22, which is a little bit shorter. You gotta find a stationary point and state the nature. That's it. But it will be question 22 next. Understanding is one thing, but you need to be able to reproduce it fully. Okay, actually, let me pause you guys here since I've got most of the answer here. But I want you guys to think about this scenario here. We've got a local maximum at 0, 1, right? And because when x equals to 0, that's also the y-intercept. So we have got the point 0 and 1 here. X equals to 0, y equals to 1. However, when trying to solve for x-intercept, you got e to the power of something equals 0, right? And e, like an exponential equation, will never cut through the x-axis, which means there's no solution. So what kind of graph is this?
An exponential graph.
Yes, they will have an exponential component to it, but how do we sketch this thing out? Like, what would the shape look like on the right hand side here, for example? What's your guess? Down, right? But how? Let's say it goes down because this is local maximum, so it goes down, and then what? On the right hand side, what should it look like? Because there's no x-intercept, and there's also no restriction for x. X can be any value. So what would that look like? Because if you continue down, it will cut through, and that's not quite right? You can't have an x-intercept. So what would it look like? Needs a bit of creativity here. What is a feature of an exponential equation?
Goes up.
Yep. And then the part that doesn't go up, there is a feature of it. It's called, start with A.
Asymptote.
Yes, there's an asymptote. What's the asymptote in this case?
Doesn't have one.
Sorry?
Well,
It does. It does have one.
y equals 0.
Y equals 0, right? So the asymptote is y equals to 0, aka the x-axis. Okay, because there's no solution, right? Y can't be 0. And the normal exponential equations, it will have the x-intercept as the asymptote. So yes, it fans out. So actually, the shape looks like somewhat like this. Does it make sense? Right? Because this part here is like an exponential equation, right? And then in the negative region, it will be the same. It will come down and it will fan out like that. So it will never touch the x-axis, but it will still follow the idea that the right hand side and the left hand side is symmetrical. Why? Look at the equation. Y is equals to e to the power, let's say write it as negative half x squared. When x is a positive or negative value, the y value is always the same, right? Because when you square positive or negative, it's the same. Which means that the right hand side and the left hand side are just symmetrical, right? It's just a reflection of each other in the y-axis. Does it make sense? Yeah. So I'm teaching you guys how to analyze the graph to predict what the shape will look like, right? And then because it's an exponential equation, e to the power of something, e to the power of something will normally have an asymptote, and in this case, the asymptote is y equals to 0 because e to the power of something cannot be equals to 0. It can't be negative either. So it's this whole part must be strictly more than 0. Okay, so the understanding of graphing of an exponential equation will help you sketch something like this. Does it make sense? Yeah. Okay, I think everyone is dying a little bit, so we'll go through the next question together. So the next question is a simple familiar one. It's question 22 here. Find the stationary point on the graph of this thing and state its nature. Right? I'll let you guys take, each of you will take like one step of this. What's the first step here, Sarah? Question 22. Okay, derive. Okay, how do we derive this one? Charlie?
I don't know.
You do know?
No.
It's in unit 2.
I don't know.
I'm sure you do know. What's the rule here? Something divides something.
Quotient.
Quotient rule, yes. What's the formula for quotient rule?
U dash v minus uv dash over v squared.
Yep. Okay, so what's u here? So we'll write y equals to that, ln x, and then u would be?
X.
And v would be?
Ln x.
Okay, so v is ln x. Now what's u dash?
1.
1. What's v dash?
1 over x.
1 over x, correct. Sarah, continue. Apply the rule. Y dash equals to?
U x times.
Wait, sorry, what was that?
It's just 1
Mm-hmm.
and then divided by
Wait. It's u dash v and then minus.
x is 1. This is x times.
Correct. X times and then x is just x times 1 over x is just 1, right? But I'll just write this step first over.
ln x squared.
Yep, ln x squared. Okay, so simplifying this, it would be ln x minus 1 over ln x everything squared. Okay, what's the next step? Charlie.
Y equals 0. Like 0.
Make what equals 0?
The root of
Yes, y dash. So 0 equals to ln x minus 1 over ln x everything squared. How do we solve this, Sarah?
Move the 2 in front of ln x.
Aha, you can't, because this one you can move. When the square is inside the brackets, then it will be 2 ln x. But for ln x and then everything squared is just the same. You can't change anything. Okay, you can only move the power to the front when it's inside the brackets, like ln inside the ln. Alright, but if it's the whole ln being squared, you can't do anything about it. So what else do we do then? When you have a fraction equals to 0, which part of it must be equals to 0?
the whole thing.
Not the whole thing. Because the whole thing is like you have 0 equals to 0. Can you divide by 0? No, you can't divide by 0. So when you have fraction a over b equals to 0, right? Which part of it must be equals to 0? A. Only the top part must be equals to 0. Does that make sense? Because 0 divided by anything is 0, right? Because like 0 over 1 is 0. 0 over 1,000 is also 0. But you can't divide by 0. So the denominator can't be 0. Which means the next step is... Sarah? Read out the next step for me. The next line.
You put, aren't you supposed to write like it ln x squared can't equal 0?
You don't need to. It's assumed.
Then doesn't mean the top is 0.
Yep. The top is 0. Yep. So read out the next line. What would that be?
0 equals 0 over...
No. So you're saying that, okay, if 0...
I said it's ln of x minus 1.
Yep, that's right. And then, Charlie, next line.
1 equals ln x.
Yep. And then continue, Charlie.
E to the power of 1 equals a.
Yep. So then x is just e, right? Or 2.7 something. Yeah, okay. So that's the stationary point and state its nature. So we need to find the y coordinate. Okay. The y coordinate is y of e, and that will be... Okay, so that would be e over ln e. What's the answer to this?
What do I go? ln?
Not quite.
I don't know.
This is ln of e, right? You can't, no, e is not a number, it's inside the function ln. So how do we simplify this one?
You should do the same thing with like the 0.
Yeah, what about it?
Can't you make the numerator 0?
No, you're solving for what this value is. It's not 0, right? It's not 0 equals to, it's y at the x value e equals to this thing. What is ln e?
1.
Is 1, yes, that's just e over 1. Does it make sense, alright? Yeah, log base e of e is 1, so that would just be e, which means the turning point, right? The turning point is at x equals e, y equals e. Now for the nature, right? Now for the nature, we need to find x and then y dash and then the shape. There's only one turning point. So x is e, y dash is 0, shape horizontal, choose a number before and after. Now this is, okay, so note that y dash is equals to, what was it again? ln x minus 1 over x squared. Okay guys, stay with me here. We are at the last step. We just need to find the nature and we're done. Now, what value would I choose before e to make that thing easier?
0.
0. You can't have ln of 0.
1.
1, correct. And what is y dash at 1? It would be ln 1 minus, wait, ln 1 minus 1 over ln 1 everything squared. What's ln 1?
I don't know.
Log of anything of 1, log base anything of 1 is always
0.
0, yes. So log base a of 1 is what number where a raised to that number equals 1. The only power that gets you 1 is 0. Which means this will have 0 minus 1 over 0. You can't divide by 0. So you can actually choose 1.
2.
2, okay. ln 2 minus 1 over ln 2 squared. How do we know whether this is positive? Remember, when you try to find a gradient, you're just trying to find whether it's positive or negative, yeah? You don't actually need the value. So is this positive or negative?
I think it's positive.
Why is it positive?
Because I think ln2 is a number.
Yes, but is it less than 1 or more than 1? Okay, I'll save you guys the trouble.
No, I think it's negative.
You need to substitute 1 over e.
Huh?
Yes, this is a special question. And then the number after that is e squared. Do you see why?
Okay. No.
Alright guys, stay with me. 1 over e is e power minus 1, right? Yeah? And if you have e to the power minus 1, that will be minus of 1 ln e, right? And then the bottom is the same. It's minus ln e everything squared. Does it make sense?
Sure.
Does it make sense? Okay, alright. If you have ln of e to the power minus 1 is the same as minus of ln e, right? Because this time you can bring a power to the front, which is minus 1.
Yeah, that part makes sense, but why are we using 1 over e and e squared?
Because 1 over e gives you e minus 1. E to the power minus 1, and that's how you can bring out the power.
Why do we want e minus 1?
So that you will get ln e in here. So if I were to write it properly, right? This one will be ln of e to the power minus 1, and then subtract 1, and then it's ln of e to the power minus 1, everything squared. Does it make sense? Yeah? And then when you get this version here, you can actually, take out the power, so the top will be minus 1 and times by ln e minus 1, and the bottom is just minus 1 ln e, right? And then everything squared. You see? The reason why we wanted e to the power something is because ln e is equals to
1.
1, that's right. So this one will just be minus 1 minus 1, that's minus 2 over 1, which is negative 2. So it's actually a very nice number, and the shape is going down. Now for e squared, right? For e squared, when you're trying to calculate y dash at e squared, it's the same thing. You would have ln of e squared minus 1 over ln of e squared, and then everything squared. What's ln of e squared? Can someone tell me?
2.
2, correct. It's 2 minus 1 over 2 squared, which is 1 over 4. So that actually gives you a positive number.
Yes.
So the nature is, this point is a local minimum.
Woo.
Okay, make sense? I think I lost you guys in the last 5 minutes there. But this is, remember, the idea is that when you're working with ln, you want to choose a power of e. Okay, so that when you take out the power, you have ln e, which is 1, and then you can get nicer numbers. Okay, that's it. I think next week we'll probably have to go back to these chapters.